Okay, welcome to topic 4, the beginning of starting to study for assessment 2 in PYC3704, Unisa Psychological Research. And we're going to be looking at the t-test. But first, we're going to do a little bit of revision. And we're going to cover page 99 to page 102. All right. So what we're doing with a z-score is comparing a single mean to a constant value, right? And then we'll go on and compare a single mean when the population standard deviation is unknown. And this is probably where our t-score will come in. Okay, now, in all statistical testing, there's a 9-step procedure. Step 1. Reformulate the research hypothesis into a statistical hypothesis. Step 2, select the appropriate level of significance, the alpha level, the alpha score, the alpha value, to test against. Okay, then step 3, choose a test statistic, such as a z-score, a t-test, or we'll do something called a chi something later. Okay, step 4, now we're starting to act. We draw a sample from the relevant population. Step 5, we calculate the sample statistics. Step 6, we calculate the test statistic. Step 7, we determine the p-value. If the p-value is less than the chosen level of significance, the alpha value, then we can reject the null hypothesis. Or if it's greater than the chosen level of significance, we don't reject it. And finally, we relate the results to the research hypothesis to come to a conclusion. So what we did in the previous topic was the z-test. This is used when we have one sample of data and we want to compare the mean of that data to a specific constant value, such as IQ, the mean of IQ scores, which is 100. Okay. Now, I did summarize the next page and a half from halfway down page 100 to the end of page 101 because it's very dense. So I used ChatGPT to summarize it, and I'm going to go ahead and share that with you now. All right. So my instruction, if you're interested and you want to use it, was summarize the following as simply as possible. And then I copied and pasted. When comparing means, the dependent variable must be at least at the interval level of measurement. An independent variable is needed to divide the population into groups. So we need one group for the dependent variable, one group for the independent variable. In a single sample test, the second group is a known population mean, a constant. Okay, this is called a single sample groups design. For example, a researcher tests a questionnaire measuring general optimism. The questionnaire provides norm values, which is within ordinal scale, in the order of least optimistic to most optimistic. And we convert the scores to a 9-point stay 9 scale, where the population, so the total is most optimistic, wildly optimistic is 9, and not optimistic at all is 0. So the population mean is 1, and the standard deviation is 1.96. The goal is to test whether this normed scale truly has a mean of 5. Okay, then I did exactly the same for the next text. The research question asks whether the general optimism scale scores in the general population are centered around the normed mean of 5. This is formulated into hypotheses. The null hypothesis is that the sample of the mean is exactly equal to 5, so there's no difference. Okay, and the alternative hypothesis is that the mean is not equal to 5. Since we only want to test if the score differs from 5 without a preferred direction, a two-tailed test is used. The focus is on testing the null hypothesis. A random sample of 50 people completes the scale, and their scores are converted to Steinheim values. The sample mean is found to be 4.5. Okay, so that's 0.1 points away from the Steinheim scale, away from the exact mean. So is this within or without the p-value? Given the known population standard deviation, sigma is 1.96, a z-test is performed with a significance level of alpha is 0.05. Okay, so we have to do this level before we can, obviously we have set this level already before we conducted the test. Okay, let's go back to our textbook, and that has nicely summarized for us all of this until we get here. So let's read this formula again. And we really need this in our long-term memories for the exam and beyond. So the standard error, okay, no, we're not, this is the Z value is the sample mean less the population mean divided by the standard error. Remember, the standard error is written as sigma x bar, okay? Because that's our test statistic, and that's our standard distribution, a single standard deviation from the mean is our standard error. In the test statistic, that bell curve is not for any sample in particular, and it's not for the population, it's for the value of the statistics and how accurate they are. Okay, so remember that our standard error is the sigma of the population, the standard deviation of the population, divided by the square root of the value n. Okay, so now we've got that far. Let's see what we're doing next. Now we're going to plug those numbers in, all right? So what was our standard deviation of the sample? 1.96. What was our n? 50. And our value that we're looking for is 5. Okay, so it will be 4.5 minus 5 divided by 1.96 over the square root of 50 is minus 0.5 over 0.277. So just looking at it before we do the calculating thing, which is always worth doing twice, I've discovered, unfortunately, is 0.5 divided by 0.2 minus 1.805. That's where the standard deviation line is. Now you go to your Z table, okay, in Appendix B, 1.805. Remember that it's going to be, it's in both, two directions, so something has to be multiplied by 2. Let's see. Okay, yes, so we're looking up 1.805, which is the same as 1.81. Okay, and this The smallest number is 0.0351. That is our p-value. However, it's got two directions. So we're going to have to multiply by 2. So it's gone from within the p-value, in which case we would reject the null hypothesis. But because it's bidirectional, it's now greater than the p-value because we've had to multiply by 2. It's now 0.07, and we cannot reject the null hypothesis in favor of the alternative hypothesis. Okay. So the scale does seem to be evenly distributed around the theoretical scale mean, which means this is actually what we want, because now we know that our scale does match the mean in the sample. That's great. Okay, so it's kind of backwards. All right, so I'll see you in the next video. Please subscribe if you don't mind doing so. I'm already halfway through to a paid channel. And, you know, we all need side hustles in South Africa, lots of them. So I would really, really appreciate it. You can leave the notifications off. I subscribe to thousands of channels and my notifications are always off. I wouldn't be able to survive with them on. Okay, see you in the next video. Thank you.